Okay, next, so for our last quantity itself, we're going to learn about your electrical resistance. So the resistance of your electric component is basically this ratio. So thankfully for us, we don't need to memorize the definition. But what is the most important is actually this formula over here. So this formula, just now earlier on in the current and voltage video itself, I previously mentioned that we don't really use the formulas here, right? We don't use V is E over Q, we don't really use I is Q over T. But which one is the most important? It is this guy right here, all right? So for some students who have trouble, basically if you need to use the pyramid, this is how it works. So the thing is, for resistance, it is R is V over I. So what exactly is resistance? Resistance is basically a quantity that actually reduces your current. So previously at the start of the first video, I already mentioned it. So if we change the formula, or basically rearrange it, not change, rearrange it, you'll see this relationship, right? So your current is voltage over resistance. So why do I write like this? Because as voltage increase, I will also increase. Okay? And on the other hand, if resistance increase, your current will actually decrease. So basically your current is affected by these two things, your voltage and your resistance itself. So how do we increase voltage? We actually use more batteries or use more cells or have a larger EMF itself. So if you want to have more current itself, you want to have a smaller resistance. So if you want to have a smaller resistance itself, you either use a smaller, a resistor with smaller resistance, or you change your variable resistor to a lower value. Okay, so for resistance itself, right? R for resistance, so for the students that don't remember, R is resistance, V is for voltage, and then current is just the only one left. Okay, so just need to remember your resistance will be carried out in ohms. So omega symbol is written like horseshoe shape. So the thing is, not just the resistors have resistance. Every single component, everything, your wires, your switch, your ammeter, your voltmeter, all of them, even your light bulbs, anything and everything, all have resistances. But, these are the assumptions, okay? The assumption is, we will assume that your wires, your switch, and your ammeters have zero resistance. That's why normally we will always ignore when you draw. So for example, if we just draw a circuit, okay, so earlier on, you should have a switch. So we will assume that you have zero resistance throughout. We are only looking at this guy and this guy. Okay, so we only look at these two which are significant. The rest we assume to be zero. Because if you actually include the wires and the switch and everything, it will get more and more complicated. Okay, and for your voltmeter itself, right? For example, oh, I forgot ammeter. Then for your voltmeter itself, if you want to measure the voltage, you'll put your voltmeter here, right? Now, for your voltmeter, it's a little bit different. Your voltmeter is actually infinite resistance. So why do we say infinite resistance? Is basically we want current to only flow over here. That's why just earlier on in your previous video itself, we don't actually count the current flowing through any voltmeter. So we only look at this part. We don't actually look at the voltmeter. We'll ignore that it's there. Why? Because we assume voltmeters have very large, to the point where the resistance is so big, the current doesn't even want to flow through it. Okay? So your resistor itself, which is this, has a fixed resistance itself. So fixed resistors usually have fixed resistance. Variable resistors, also known as your rheostat, have changeable resistance. So you can change from a minimum number to a maximum number, from 0 to something. Okay, so this is your resistance itself. Do take note, this is your most important formula. Out of all the electricity questions, I have never seen a single question that doesn't test this formula. This is your bread and butter. You use it everywhere you go. Okay. Then for your resistivity. Now do take note, this is not resistance. Your resistivity is this over here. Okay, so your R is your resistance. So basically what this means is that as length increase, resistance increase. Okay, as your area decrease. Sorry, if we say area increase, now if you notice your area is in your denominator, right? So you have the opposite effect, you decrease. Okay, then as your resistivity increase, your resistance also increase. So whatever is in your numerator itself will have the same effect. Whatever is in your denominator will be the opposite effect. So do take note about this, because some questions will actually need you to use kind of like maths, the ratio itself, and then you just want to know what's your new resistance at the end of the thing itself. All right, so later when we do some practice or work example on this, it will make more sense to you. So the thing is, this term resistivity, right, is a fixed quantity. So how to say? So resistance doesn't change. It's kind of like density itself. It's depends on the material. So if your material is the same, we are using copper wires. If you are just comparing copper wires, all copper wires have the same resistivity. However, if you change the material to silver or another metal itself, your resistivity will change. Okay? From your resistivity, your temperature also affects your resistance because of this. So actually, you can skip the part in the middle. You can just say as temperature increases, the resistance will increase. But if they ask you 2 marks, what happens when temperature increase? What happens to resistance? You also include your resistivity part, just in case. Okay, so you can see the relationship over here. Longer means higher, smaller means higher, and stuff like that. Okay, so let me just briefly sketch you what I mean by the wires. So this is your default wire with a length and area. Okay, and your resistance is R. Okay, rho L over A. Okay, then we have, let's say, a longer wire, which is 2 times 2L, same A. What happens to your resistance? Your resistance now is 2L over A. Okay, this is R2. So what happens is, if you take out the 2, you have rho L over A, which is 2 times of the original. Can you see that? So basically, if you were to do a thicker, but with the same length, 2A, what happens? Your R3 is rho L over 2A, right? Then you solve. You actually end up with half R. So the thing is, you need to take note. Some questions, they are not so nice to give you area. Some questions will give you the radius. They'll give you the diameter. So you might need to use pi r square because a wire is a cylinder. Okay? And for especially the IP students, they are not going to just change one factor. They're going to change 2 at the same time. They're going to change the length. They're going to change the area. You need to know and how to solve. So basically, it's a lot of maths. You just need to substitute in your new values, compare it with your original rho L over A, and then you just solve for your value of your resistance. So over here, you have a rheostat. So if you don't know what's a rheostat, remember it's your variable resistor, and they tell you my EMF is 3.8 volts. So just take note, some questions, they are not so nice to actually write it down for you. You might want to include it yourself as well. So they tell us, calculate the resistance R when the rheostat of when your current ammeter reading is this. So first thing we want to ask ourselves is I, right? 500 mA. We change it to amperes. Because we need to use SI units, your voltage remains unchanged. It is still voltage. So now we want to find resistance. Write the formula first. Throw in your values. 0.50. We end up with 7.6 ohms. Okay. Then if you still are not sure how it works, basically your current flows in this direction. Okay, so describe how your current changes when your real resistance of rheostat decrease. So if you are not sure, first thing, just at the side, okay? We know that current, because you want to find change in current, right? We make current the subject. I is V over R. So if R decrease, what happens is current will increase because of this. So you can see you have your three words here, right? You have your voltage, you have your resistance, you have current. So try to always put all three of them inside. So for the same EMF of the battery, current will increase as resistance decreases. So you can see I wrote this very, very briefly itself. So what you want to say is, to be more specific, resistance of the rheostat. Now, why do I need to write so much like this? Because there are many, many different resistance itself. It can be the resistance of the whole circuit, it can be resistance of the whatever components that you have. Because in later parts itself, when you are actually doing your electricity questions, you actually realize that there's actually a lot of resistance. Can be R1, R2, R3, can be total R, got a lot of different resistance itself. So we need to be a little bit more specific. Okay, so you can see we have your, okay. So you can see now EMF, right? If the question doesn't tell you EMF, you need to take note whether you need to increase or decrease, how to say, to put it in full words, electromotive force or EMF itself. You need to double check. If your question already says EMF, then you can use EMF. But if your question doesn't say EMF, then you need to say electromotive force or your voltage of the battery. So you can see we have your V, we have your I, we have your R. Just include it, all three of them inside. And that's the relationship. So if you think about it, resistance is like the obstacle that's blocking my current from flowing, right? So if there's less obstacles, I can flow more easily. So because I can flow more easily, my current will increase. Now over here, you have a 50 cm long wire. You have a ammeter battery of this voltage. So current is this value. So this is current, this is voltage. You want to find resistance. So ask yourself, everything is nice. So all we need to do is R is V over I. What is V? 3.0. What is I? 0.15. Throw in your numbers. You end up with 20 ohms. Okay. So R is 20 ohms for this 15 cm long wire itself. And next, the question tells you, you have now twice the length, half the area. What is your new resistance? Okay, and then what's your new current? So there's a few things you need to take note. First thing is your new R. So how do we write it? Okay, so before we write new R, we need to understand what's your original first. Original is this. Okay, so it is this value, which is 20 ohms. Okay, so next, ask yourself, what's your new R? First thing, we're using the same type of wire because the question never specify. You're going to use twice the length. You're going to use half the area. So if you 2 divided by half, you end up with 4. So this is rho L over A. This is 4 times of your original, which is 4 times 20, and with 80 ohms. Okay, so this is just a lot of maths. So you found your new resistance already, so you want to find your new I. Okay, so it's new I is new V over new R. So you can see new, we always make sure that they are the same. So it's 3 divided by your 80 now. So you press the calculator, you should end up with a fairly weird number. Okay, so 0.0375. And because I use 2SF, I might need to round up to, and this is current, 2SF. Okay, so you have your two answers. You have your 80 ohms and you have your 0.038 amperes. Next, if your diameter is of the 50 cm wire is 5 mm, what is resistivity? So do take note, we are talking about your original wire. Okay, so we'll write the formula again. R is rho L over A. Now the question is asking us what is rho. Okay, so we make rho the subject, or you can just put in your numbers first and then you try to solve. You have 20 ohms, you have rho, and L is 50 cm. Because 50 cm is not SI units, what you want to do is you want to change it to SI units. And your diameter, so your area, which is pi r squared, is going to be pi 2.5, because this diameter, divided by 1000 and big square. Don't forget the square. So now all you need to do is solve what is rho. Okay, so basically you have your 20 pi 2.5 over 1000 square over. Now, why am I keeping everything as it is because if you were to press the calculator itself, you keep having weird numbers because of the pi. So we try to keep it as it is so that you will get a correct, not correct answer. You'll get a more precise answer. Okay, and on top, this one is 1000, because it's mm. Okay, so it's 1, 2, 3. There's 3 zeros on top. Okay, then don't forget the square, and then you have 50 over 100. Look, so you should end up with quite a small value, 78540. And because we have so many numbers, the smallest you can see is 2.5, is 2SF or 50 or 20, right? So we will keep it as is, we use 2SF, 79. And this is resistivity. So resistivity itself, the units is a bit quirkier. If I'm not wrong, it is ohms meter. Okay, so you can see how often resistivity is not very, very commonly tested itself. So the units, you might need to be a little bit more careful. Okay, you might want to spend some time to memorize the formula, the units, sorry. Okay, if you cannot memorize the units, one way you can do it is, if I want to have resistance, you can make it the subject. It is RA over L. So ohms times meter square divided by meter. So meter square divided by meters, you end up with meters, so it's ohm meter. Something like that. Okay. So just take note, this part a little less common. The more common one would be the one on top. Okay, but if they do test this, you need to make sure that you know how to find it as well. Most of the time, they'll actually give you the units for resistivity, probably somewhere in the table or something like that.